Hello, world. Welcome to Code or Not to Code. I'm Mili Eva. I'm really happy to be here today. And I'm here with Stefan. How are you doing, Stefan?
We talked about it. I usually say excited. No, I used to say nervous, then I said excited. Now, today I'm very nervous.
Me too. We have a super exciting episode for you today, as we will be using Roslyn and its Workspaces APIs to interact with our using directives and further implement our tool. But before we get into that, let's have a look at the newsflash section of our show. Again, this is usually where we sort of look at what's new in the tech world, what news we have. But as it was the 1st of April, yesterday, we wanted to switch it up a bit and show you our compilation of the best fake news we found yesterday in the tech world. First, obviously, MATLAB announcing that they will be switching to Python as their primary language, which must have come as a shock to the entire community, but they said that it's the best way forward for them, and they will offer support throughout the switch. And yeah, speaking of Python, the other news that we found is that Python will be renamed to Viper, which I also thought was really, really funny. Yes.
They should sync the announcements, shouldn't they?
They should. They must have been MATLAB, must have been also like really. We switched to Python and now Python doesn't exist anymore. Fabulous. Yes?
And one that got me, I wasn't thinking that yesterday actually was the 1st of April. It always catches me off guard. So I was like, for 1.5 seconds too long, was actually surprised to this German, but it says that Elon Musk is buying Steam. And it shocked me for 1.2 seconds.
If you have any great April Fool's tech news that you want to share with us, please write them in the chat and we'll send the link and we'll share them as well. I always love those. So yes, please do if you found any. Cool. Yes, what have we, let's have a look what we did last time and what we want to do today.
So last time, putting in the chat, we had, well, so in 2 episodes before, we looked at the 3 major testing frameworks and the assertion libraries in .NET. And after a survey, we then decided to go with XUnit. And last time, we then have implemented a bunch of XUnit tests for our .NET tool. Let's have a brief look at because our .NET tool is going to count, sum up and count all the local usings, and then offers them to change them into global usings. So we wrote some tests where we find, we put in C# code as documents, and then find for example, the system using occurs one time. And if we have multiple usings, we find all of them, they occur one time. If we have a more complex test, we see that we sum, for example, up system occurs 3 times, where system.io occurs 2 times, and so on. So we might like to show which usings are the most common and perhaps most prevalent to be moved into a global using, where we then have basically the other test, where we, perhaps let's zoom in one more, where we then change this using into, well, since this document doesn't have anything else, it will be empty, and we'll be left with a new document that contains only the global using. And perhaps one more complex test down here, we would, if we ask to remove or globalize the system.collections.generic using, then in the input, they're here, but then in the changed documents, we can't find them anymore. And yeah, we'll be using Roslyn to implement this today.
And for that, we have a very special guest for you. David Wenger is here, tuning in all the way from Australia. He is a developer on the Roslyn IDE team at Microsoft, and he agreed to help us today with the implementation. We are so grateful for having you on our show. Thank you so much for joining. How are you going?
Thank you for inviting me. I'm going well. How are you?
Fabulous. I'm really excited.
Good.
Thank you so much for defying the time zone difference.
Yes.
But it appears
that's right.
it appears that now is a good time because we went plus 1 hour like last week, and you just today going back 1 hour. Aren't
Yes, that's right. Everyone in this house woke up confused this morning.
Cool.
It's, I'm happy for the overlap because I used to watch your streams, Stefan, on I think it was just before dinner time, and then daylight savings shift happened, and then it got to be an inconvenient time, and so I'm kind of happy that it's back at this, but then at the same time, with everyone I work with in Redmond in Seattle, they also went into daylight savings. Oh no, sorry, I think they went into daylight savings a couple of weeks ago, and so now we're further apart from the US, so it's all weird. I don't know. Yeah.
Oh yeah, because there is the day. It goes the other way. Yeah.
Yes, I'm going into winter. It's getting cold and dark and all those things.
I just realized I've never been in the southern hemisphere.
Well, most people aren't, so you're okay.
We've actually met at NDC London end of January. It was very cool to meet you there. I've seen you also did a session on the Unhandled Exception podcast on Hot Reload.
Yes.
You also, what I really liked is your C# 11 talk from NDC Melbourne. You also gave that in London. I'm afraid I missed it, but airport and such.
The video should be up soon. The interesting thing about that talk is in Melbourne I did it. That was in June, and then C# 11 came out in November. So then when I did it in London in January, it was much easier because they didn't ship some features that I did talk about, and I got to actually talk about the end results rather than in June when I had well, this is probably what's going to happen, but I can't demo anything. So it's kind of, I think it'll be interesting to compare those two once the London one is out, but we'll see.
I watched the recording. I think you said this was the easiest talk you ever did, wasn't it?
Yeah. Sometimes these ones are easy because it's just, I don't work on the compiler. I just go to the compiler website and get the list of changes and, run through the list. I don't have to come up with a storyline or slides or anything. That's just it's all given to me. So yeah, they're kind of easy.
Cool. I'll also post your website in the chat. That people can follow up with some of your work, for example, the trains.net project, and also a project that I'm using a lot, the decompilation differ.
Yeah. I used to use this a lot too, but I actually haven't for a while. I don't even remember if I updated it for .NET 6, let alone 7, but I'm glad it still works.
And this will follow in the chat as well, and then later on the YouTube recording, it will be in the description of the video.
Cool.
Cool. I guess now it's a go time to talk a little bit about Roslyn. Could you give us a brief introduction, what it is, and which aspects we are going to have a closer look at today?
Sure. So Roslyn is a few things. Partly it's a team name at Microsoft, which is the team I'm on, which encompasses lots of sort of areas of things. But most people sort of think of it as the C# compiler. And it also powers the what we would call the C# IDE experience. So when it's like I'm on the IDE team, meaning I'm not on the compiler team, but I still work on Roslyn and I still work in the Roslyn repo, but I work on the more of the stuff that you see in Visual Studio Code, Visual Studio for Mac, etc. Specifically, my work there is around hot reload and edit and continue, which is why I talked about it on the podcast. But you can't escape the things we'll be doing today. So at the heart of Roslyn, there exists a model to represent your code. And it starts, so at the very top, there's something called a workspace. So this, well, I guess on this diagram at the very top, there's a host environment, but we'll skip that. But so there's a workspace that, and this the workspace holds everything in Roslyn. And there's only ever one workspace as far as Roslyn's concerned. And the way that I think about this, because I use Visual Studio, is just thinking about the tree in the Solution Explorer in Visual Studio. You can sort of think about the workspace is Visual Studio itself. And so there's one of them, and there's one main Visual Studio window. And then there's a solution that you have open. There's also only one solution, but there's 3 on the screen here, and I'll get to that in a second. And then the solution has projects. Projects have documents. So if you think about it in the Solution Explorer, you have your solution, you have your projects, you have files under them. And then inside the documents is where we get to the actual code, which is, as it says there, there's text, there's syntax, there's symbols. Symbols also is referred to as semantic information. We'll get to all that. The key thing with the way Roslyn works, and the reason there's 3 solutions on the screen there, Roslyn is designed from the ground up to be completely immutable, which means you can't change it. So everything you get from, well, below the workspace level, so from solution and down, if you ever access any of this in code, you cannot change that data. And that kind of sounds a bit weird, because if you think about what a user is doing in Visual Studio, they're typing in a document, they're constantly changing. So how does that work? And the way it works is that every single change you make to a solution, a project, a document, any of the syntax, anywhere in the file, it always produces an entirely new copy of everything. Now, it's not strictly speaking a copy, because there's optimizations for saving memory, but you can think of it as a copy. And so that's where the solution 1, 2, 3 thing comes along there. As you use Roslyn, you progress through these sort of snapshots of your code. That's the sort of the biggest, sometimes it's a gotcha when you're working with Roslyn. It can be a bit of a trap. You call the add project method, and it's kind of like when you're starting out with C# and you call, you call a string and you call to lower, and then you check the string and it hasn't changed. It's kind of the same things. It's very easy to say, oh, add a document to this project. And then you check that the project doesn't have any documents in it. So you've got to remember that they're always giving you back new information. But yeah, so it's done. It's done for performance reasons, because having immutable snapshots, and this is generally true in programming, but having immutable snapshots means you don't need to worry about threading and about multiple things changing your data as you go. You can imagine in Roslyn, if we're asked to get the list of errors in a file, C# code errors, if we start processing that file and the file changes because the user is typing, then either the code has to be super complicated to deal with that, or it's going to get the wrong results. So the way around that is, at the start of, you think about it, imagine there's a method called get errors. At the start of that method, it gets the document that we want to work on. And no matter what happens, we know 100% certain that that document we got at the start cannot change, because it is impossible to change. If there was typing going on, if there was a light bulb executing, if you did a git check out, anything, it would be a different copy of the document that was sort of the result of that modification. So your code that you're writing to get these errors is easy. It just processes the document it was given, and it doesn't worry about the rest. The complexity then is sort of above that line, where after you have changed something, you have to apply that change to the workspace. So there's only one workspace. A workspace has one solution that it points to at a time. So as you get these new solutions and you go through time changing and getting new versions, you have to apply that change back. And so that's where there's a bunch of code to say, well, I want to apply this change, but this is now conflicting because this changed in the middle. All sorts of smarts and all sorts of smart people worked out how to make that work. And it's good because we don't have to worry about it. So it makes our life easier by just, here's something that we can access, and we return a new something, and everything else will work out, if that makes sense.
I think I now realize why the analyzer and code fixer APIs, why they are all async and having a cancellation token. Is it because so if a change happens, then Visual Studio will invoke that cancellation?
Yes.
I see.
Yeah, absolutely. So cancellation is very important for, again, just for performance, for saving work. Yeah, if something changes and we know that whatever work was happening before is now not going to be valid, then we cancel it and start a new one up or whatever it is. That's also why if you look at the analyzer, there's some helper classes that you might have used if you've ever written an analyzer or a code fixer, but at the very heart of it, an analyzer is given a solution and it returns a solution. And that's because it's, well, sorry, not an analyzer, a code fix. A code fixer's job is to change the code. And so it gets given a solution with some code, and it is expected to do some work, and it will return an entirely new solution. Most of the time, you actually inherit from a class that is like a document code fix provider. And that's just some internal helpers that let you work on one file and return one file. But behind the scenes, that one file is then sort of combined together. And everything always has to work on a solution level, because that's what can be applied to the workspace. If you change a single, if you add a comment to a single bit of syntax in your code fix provider, you're producing an entirely new solution because everything up the tree is immutable.
I see. I always thought this is done because to enable Control C, undo redo functionality. Never thought about the multi-threading aspect.
No, actually, undo is not. There's code in Roslyn to deal with undo, but it's only just telling Visual Studio when we want to sort of set an undo marker. I think Visual Studio just does it based on text. No, it's a lot of it's for cancellation, for performance, for doing background work. As I say, there's lots of smarts in Roslyn to make all of this performant. So if you do produce a new, let's say you add a comment to a document, you don't want to actually have to copy your entire solution object into a new solution object, because that would use up a lot of memory. So it's very smart about only modifying that one little piece of the tree that you have changed, and everything above there will share the same. So they'll share the same objects as the previous snapshot you got, but it won't be possible for you to sort of navigate into the wrong snapshot, because then everything would break. So
Is that the red tree, green tree thing, or am I mixing up stuff? I'm not really sure what that is actually.
It is. I must admit, I'm not. I forget which one's red and which one's green. I think red is the one that is modified, and green is the read-only one. But I might have that backwards. I honestly don't know. The colors are meaningless, basically. The story goes that when they were designing Roslyn, they were standing around a whiteboard, and they just were talking about this dual tree approach, and they used a red marker for one and a green marker for the other, and that's how they got their names, and that's how they stuck. So I forget which one's which, but yes, essentially one of them is mutable, and so that's what lets everything. So if you make a change, you can imagine your tree structure. If you make a change in the middle, then everything below there might change, but everything above there can stay the same.
I see. Cool. So if I would now change like a comment, how does this actually now look like on a document level?
Yeah. So I was going to say Sharp Labs. Good one to bring up now. So inside a document, so there's a couple of, I guess, in my brain, I think of Roslyn in terms of two different, well, not different, but two. There's a separation. There's solutions, projects, and documents, and that's working with the structure of your solution, what files are in it, how are they grouped together, what references there are, what analyzers are run, etc., etc. Once you get inside a document, it's sort of like a different model, and that's where we head into the syntax tree, which is still a tree, still immutable. That's where the red-green trees really come in. Like there's not really a green or red tree for documents. It's at the syntax level where these things come in. But everything in your code is expressed as a syntax tree, which is true of, I think all programming languages. Roslyn's is, you might have heard the term abstract syntax tree. Roslyn's is not an abstract syntax tree. It's a concrete syntax tree. What that means is that every single thing in your file is represented in the tree, and can be converted from the tree back into text, and it will be exactly the same. So where that becomes interesting for compiler authors is that means the tree has to be able to fully realize completely invalid code, right? Complete nonsense code has to still be able to be parsed into something and then converted back. The something doesn't have to make sense or compile, but it has to be represented. So what that means is the Roslyn syntax tree tends to be extremely detailed, to the point of it's actually kind of annoying sometimes to work with, because it's easy to fall into a trap when you start working with syntax trees. You know, this code here, for example, we have a class declaration, and we can see there's a public keyword and a class keyword and an identifier. That all makes sense, right? The identifier is the name of the class. That all makes sense. But you could put a comment in between the word class and the actual class name. You could put 3 new lines in there, and all of that has to be represented in the tree. So if you're not careful with how you're looking at the tree and you go, well, next to the class, there must be something. Well, there might not. There might be some white space in the middle. Conversely, if you're looking at a tree, and this isn't, you can't do this by typing C#, but if you're producing a tree, you can actually produce a tree that has no white space. And then when you go to convert that to a file, to actual write that to a file, you might end up with public class, my class, all one word, and then it doesn't compile. So you have to deal with white space. It's called trivia in the syntax tree and in Roslyn, as you can see. Yep, on the right. The joke internally is, of course, that it should have been called complexia, because it's not trivial at all to deal with. Trivia generally means you can ignore it, but you can't ignore it. And in fact, sometimes the trivia is very important, like XML comments are trivia, but of course they're XML, so they're structured. And so anyway, we could talk about it for hours. But in general, the way to think about it is there is a tree that represents your code. There is a node for everything in your code, and those nodes and navigating those nodes is how you programmatically understand the code. So that public class, my class, is a class declaration. That's a type of node. It will have inside it, and this isn't represented in the actual syntax tree, but that in the API of Roslyn, a class declaration will have members. And so this will have one member, which is M, which is a method declaration. And so you navigate through the tree like this. So the good thing about Roslyn is the actual syntax node, the classes that represent these things, are very well written, and they have helpers that point to everything you need. So on a class declaration, there will be a property called name, and that will give you the spot in the tree that is the class name. It won't give you the class name as a string. It's not information about the class, but it'll point you to the my class identifier token, which is good because, as you know, previously discussed, if you've got comments in the way or white space or whatever, you don't have to get there yourself. The compiler or the parser got there, so it remembers it. So that would point to that. And so then you can navigate this tree and reason about your code to a certain extent. What you can't do is, so syntax is just the code as you have typed it, but it doesn't have any meaning. Syntax doesn't have meaning. The compiler needs to obviously ascribe some meaning to things, but that happens in a separate pass, and that's where we get semantic information, or what we call symbols. So as an example, if you were to duplicate that method declaration and have 2 methods with the same name, that is not valid C# in the way that we think about it, but as a syntax tree, that is perfectly valid. It's just a class and it has a method, and a method can go here, and that's fine. It's the semantic and the understanding of what does this method mean that gives us the sort of realization that, oh, this means a method on my class called my method declaration, and here's another one and it has the same signature, and we can't allow that. So it's only through understanding the code that we get that information. And so that's where we bring in the concept of semantics, and semantics is the meaning, but they're represented with symbols, which is another tree that exists inside a document. So they're kind of next to each other, syntax and symbols, and you can get from one to the other. You can get from, you can go either way. Going from syntax to symbols is a little more complicated, but you can. And so that's the other way that you might navigate around a document, is you could use the symbols, which is basically saying, not just give me the code as it is written, but give me the meaning of the code. And so in this case, this symbol that we're looking at would be a type declaration, a class symbol, a named type symbol. That's the one. Sorry, I forgot the name for a second. So this would, my class here would be a named type symbol. And again, that would have methods in it, and they would be method symbols. And there's property symbols and field symbols and et cetera, et cetera, et cetera. And so you can still navigate through this tree. You can go to a named type and you can get all of its members again. You can look at a method symbol and get all of its parameters, et cetera. But the symbol information, it's not necessarily one-to-one with the syntax, and vice versa. So with things like partial methods, we get these things where a symbol can have multiple spots where it's declared, and they could be in different files. What else could we do that's confusing?
So like it would be two different nodes, but it would be just one symbol at the end. Do I get that right?
Yes, two different syntax nodes. They would both represent the same symbol. And so on the symbol, there's a declaring syntax references property, and it's an array. Normally, you expect it to have one thing in the array, but in this case, it would have two. And so you get into interesting things here, like, so for example, if you leave off public from one of those declarations. So that's still a public class, and the symbol will tell you that's public. But if you just look at syntax, you may not know what the visibility is. You have to go through the entire project essentially to know what the visibility is, because you have to wait till you've seen the other spot. So depends what you're trying to do as to which one is better to use. For the using statements, pretty much only syntax, because, in fact, there isn't really, there's symbolic information that is relevant to using statements, but that's just about sort of whether they're valid. For the task that this tool has to do, probably don't really need symbols at all. If you wanted to extend it to finding unused usings, then you would need symbols.
Oh,
I see.
So to know whether a using is used, you have to know what it means. And as soon as you need to know what it means, now we're talking semantics. Make sense?
I see. Absolutely. So
that was completely off the cuff, so I have no idea if I rambled or anything.
No. Actually, I learned something already. I learned a lot already.
Good.
So I guess we could basically, if I understand you right, so if we want to find out whether a using directive is a global one or a local one, we can either go by syntax, by seeing if this keyword exists, or going by symbols, and I guess there is then a property is global or something.
No. So good question. So this is where, and again, it's an easy trap to fall into. Symbols don't necessarily represent everything about syntax. So C# syntax is designed to be a very clear and concise way of expressing C# code. Symbols is not, right? And you don't create them directly, so it doesn't matter. So a global using there is no concept of that in symbols at all. A global using is purely syntax, and the compiler just essentially copies that into every file. So there's no symbolic information for symbols, for global usings. This is true, for example, what's a good example? Some of the things like, records is a good example. a record in C#, you can think of it as a different type of thing you can create. You can create a class, a struct, a record. But symbolically, a record is just a class, or a struct if you define it as a struct. It's not a new type of thing in terms of its meaning. It's just a new type of thing in terms of its syntax. And so the way to tell whether a symbol is a record is you actually go and look for a specific method being declared that the compiler will generate. Or sometimes you have to go and look for some attribute the compiler will emit or something. So symbols is kind of a lower level concept, I guess. Symbols maps more to, well, it's not quite the same, but it's almost, you can almost think of it as, it's almost language agnostic. It's not language agnostic at all, but it almost is. Well, in fact, yeah. So C# code compiles to .NET assemblies. .NET have certain concepts, right? .NET has methods, properties, fields, but there's no such thing as a record in .NET. There's no such thing as a using statement in .NET. Those are all C# concepts. And so that's sort of the way to sort of think about syntax versus symbols. It's not quite the best metaphor, but it generally works. Yeah, so sometimes the only way to find out what something is, if you get given a symbol and you want to find out how was this declared, or you know, is this a something, sometimes the only way to do that is to have the source code and to look at the syntax, because some of it there is no representation in the resulting DLL at all. Some of the things like you know, like scoped modifiers and things around memory safety and what you can and can't do, those all just inform the compiler what to check for and what to error on, but they don't actually affect the compiled code at all at runtime. Yes, so as you've pulled up here, we can see this, you define this as a record class, but it's just a class. There is no and there's no attribute that says this is a record. If you scroll down, what you will find is a clone method with a $sign in it, somewhere down here.
There it is.
There it is. So this method is interesting because it has a name that you as a C# developer cannot create. That is an invalid name in C#, but it's not invalid in a .NET assembly. So the compiler creates this method knowing that you couldn't possibly create it, so it's not going to clash with anything. And then because no one can create this method anywhere else, we can use that to tell that this was a record.
I see. So a decompiler now could understand this structure and from there imply that this may have been, well, most likely has been written as a record originally, if it was written in C#.
Yes. And in fact, not just to decompile, that's exactly how edit and continue or hot reload works. When you, if you add a method to something, there's a bit of code that says, does the class this method was added to have a clone method? If so, do something different because this was a record. So sometimes even in Roslyn, we have to use these little tricks.
I see.
And some of the little tricks are part of the compiler API. So it's not quite the great metaphor that I've said, because when you actually get down to it, you know, I think now there is an isRecord property on a type symbol. There wasn't originally, but I think there is now. It just checks for this method. So if you look at the API, it's not quite exactly as I said it was, but conceptually, yeah.
Wow. Cool. I will afterwards need to definitely rewatch this section. There's a lot of knowledge in it. Thank you so much.
That's all right. The details are always, you know, you could go into a lot of depth. I mean, luckily for the most part, we don't need to think about it, you know, in our day-to-day jobs. But when you start working with Roslyn, particularly if you start trying to reason about, well, either symbols or syntax, there's usually some horrible edge case that you have to consider that you never would type. You know, a sane person wouldn't create, but it happens all the time. In fact, it actually happened to me last week. I'd written some code that worked with properties, and I didn't consider that it's possible to write a write-only property. And so my code didn't work if you had a property that only had a set and didn't have a get. And I just completely didn't think about it because, of course, I never write properties that don't have gets because that just seems weird to me. But it's totally, it's totally legal. You have to actually put in the braces and do it properly.
Mm-hmm.
Yeah. But it's totally legal C#, but I never do it. So I didn't think of it. But of course, where I was working, which was actually in the Razor compiler, not Roslyn, but same thing. It was you got to equals value.
Excuse me?
Your setting. So field equals value.
Yes, that's right.
I
haven't written these in languages. Yes.
Yeah,
I see.
But so that's perfectly valid C# code. But for the code, I was writing code that looked at the syntax and it just blindly assumed there would be a get on every property, because why wouldn't there be? Well, it turns out sometimes there isn't. And there's always these little edge cases. And in fact, every time I've ever done anything in the Razor compiler, one of the C# compiler devs will come along and tell me, oh no, hang on, what about this case? I was like, but it's fun.
We do have a question from the audience. N. Knusperer is asking, what led to the design decision that Roslyn cannot be used for implementing a new language for the CLR, the Common Language Runtime? While some constructs are obviously specific to C# or VB.NET, most of them are language agnostic and exist in some form in other languages. Think of it as comparing to LVM.
I would, it's not a good answer, but I would say the reason that I don't think there was a decision to stop Roslyn being that. That's just not what Roslyn is. Roslyn is a compiler for C# and VB. It replaced native compilers that are written in C++ for C# and VB. So it's not the first. It's not the first compiler written for C# and VB. Its job was to replace C++ code with C# and VB. So the C# compiler is written in C# and the VB compiler is written in VB. There was some decisions early on about how much code should be shared and not shared. So I think originally there was a plan that it would be completely separate, but there is a common layer between C# and VB, it's sort of inside Roslyn, but it was never, it was never decided to not be general purpose because that was never the goal. I'm not sure it could be. Ultimately, Roslyn is representing high-level languages, and I think they're probably a bit too opinionated to be as generic as LLVM, maybe. Don't know.
So could Roslyn be F# or used for F#, or will this be then a separate component?
The F# compiler is completely separate. It's not a Roslyn compiler. It's written in F#. There's no technical reason you couldn't use Roslyn to create a compiler for any language. It's not, it's just effort, and that wasn't a goal, and so no one made the effort. There's a couple of languages I know of that have been heavily inspired by Roslyn, and I think a couple that forked the repo and tried to build on top of it. It's it's purely an exercise in how much effort, and I'm not sure which one is easier, like starting from scratch on a new language versus using Roslyn, because there's probably some quirks in there that if they don't apply to your language, you'd be forever fighting. But the general patterns in Roslyn have definitely been copied by other people creating languages, although not production ones, just for fun.
Cool. Eva, do you have some more questions?
No questions from me, but thank you so much. This is super, super cool and really, really interesting. I love it.
I find it interesting too. I quite like one of my kind of hobbies is so I don't generally keep up with the C# language design discussions. I just too much time taken to try to keep up with all of it. But I do love when new language features are available. basically going into SharpLab and playing with them and just seeing what they do and seeing how they're implemented, and then trying to sort of reverse engineer, like, well, why would that have happened? And it's good fun. I quite like at least knowing how the language works, but I'm not fussy enough to try and direct how it works or think that I have any valid opinions. Just a casual observer.
Cool. Shall we get coding?
Yes, let's get into it.
All right. So if we were now to implement, because what we did last time, we applied maybe a little bit too strict test-driven development. We returned exactly what the test demanded us to do. So I guess we can't implement all the use cases in the world in this method. So how could we use Roslyn to do this more generically?
So this is where I have to ask you questions, because it kind of depends on what your aim is. And there's a few ways this could go. So looking at these tests, you have the contents of documents being passed in, which is fine. So if that's the case, and if you want to constrain this just to using statements, you really only need syntax, because what you're looking for is, given in this set of documents, how many using statements point to a namespace that is, this string of characters. You don't need to know whether it's valid or whether these two namespaces are in the same assembly or anything about the meaning. So you don't need semantics. You could just use syntax. And you can so the Roslyn API can be used directly at the syntax level. You can say, parse this tree, give it a string of C#, and it will give you back syntax nodes. So because syntax doesn't have meaning, you can just give it a chunk of code and it'll just work it out. When you need meaning, that's when you need to get a bit more serious, and you need documents and projects, and you need references. References in particular then bring in the question of, what version of .NET are you targeting, right? Etc. So you kind of need to work out, where do you want to go with this? Of course, giving your tool the contents of files might not be the way you want to go, because giving it file names might be easier. And so maybe your tool at least creates a project in memory and just puts all the documents in so that it can parse them easily. Or you could have your tool actually load a CS Proj project and load in MS Build concepts and do all that. Really anywhere, Roslyn is part of all of this. It really depends what you want to do. I guess the biggest thing I would think about is, if you wanted to convert your tool into a proper code fix one day, so that, in Visual Studio Code, you could click the light bulb on a using statement and it could say, you've used this in 7 files out of 10, make it a global. That might, influence your decision as well. So we can start somewhere. The easiest way to start is just by parsing a syntax tree, though. So
let's start easy, and then I guess so that the ultimate goal is then so that the tool that we then deploy via NuGet package could accept either a CS Proj or also an entire solution. So we could transfer a specific or list all the usings from all projects in that solution. But this is version, I don't know when.
But that's cool. So the good thing about it, though, is, I think using Roslyn like this, it's a very layered approach. So your tests are C# code. And so if we write code that works on a syntax tree, we get the test to pass. When you then layer in MS Build or documents or projects or solutions, at some point you will have to get to the syntax tree. And so all of the code that we write tonight will still work.
Sounds good. Sounds like a plan.
So let's start with the parsing, just with the parsing at first place, and I guess we can extend that. So if we jump into the using counter, I guess let's get rid of the lie. So how could we now go ahead and assuming that those strings are C# strings, convert them into trees.
Yes. Well, that's a very good. That's a big assumption, but it's just going to be so much easier if we just make that assumption. Don't try and support VB. That's the first thing I'll say. So the first thing we want to do is add a NuGet package, I guess. And we can probably cheat a little bit, and we can add the Workspaces NuGet package, and it will bring in a bunch of stuff that we don't need yet, but we'll get there.
So this will be
C#
the Microsoft
Workspaces.
Kubernetes C# Workspaces, right?
Yes, and if you look at the versions tab, the way Roslyn generally works as versions is you take the current version of Visual Studio and you minus 14. Is that 14? No, 13. 13. I don't know why, and I'm not sure that's the reason, but it turns out that's how it's lined up. So 4.6-1 is essentially Visual Studio 17.6 preview 1. So that's how you do it. For using statements, they don't change much. Any version will work. But, if you wanted, well, since you're talking global usings, I guess, you don't want to be too old because eventually you get down to a version of Roslyn that doesn't understand global usings. But so whether it's 4.5.0 or 4.6-1, either one works.
Let's go with 4.5.0. I guess the least we would need is 4.0.1 because that's the first
That's
RC C#10 version, right?
Yes, I think so. I'm very bad at remembering years, but I think that's right.
I think there is a link, right? I always look at this link.
Yes.
Where it says which Roslyn version
is 4.0 C#
which support, and also the Visual Studio version. Yeah. Yeah. There is the pattern. Yeah.
Yep.
Okay. Cool. So let's go use the 4.5.0. Let's go into our project and this is an item group. And let's add that NuGet package. Restore, yes, please. And it's restored, cool.
Yeah, so Roslyn is C# and VB. And as I said, there's also a common layer. And so that's the thing to be careful of, that you're using the right types here. So I'm pretty sure you just want to type in C# syntax tree.parse, I think is a method. It's a static method.
Syntax tree, let's see.
Yeah.
If in Microsoft Kubernetes is C#.
Yep. And then, parse text.
Parse text.
So that will
for each, right?
Yes.
Of our documents.
Yes. So the thing to sort of make sure we pay attention to is, so C# syntax tree will inherit from syntax tree, and there's also a basic syntax tree. Sometimes you get back the language agnostic models, and you need to cast them back up to their language versions. That's the.
So this one is actually the common syntax tree. So
parse text is giving back a comment, which, I mean, I think it'll be fine, but it is just something to. It can be a trap if you end up looking in IntelliSense and there's not what you expect to see on this object. Check that you don't need to cast it up to a higher one.
Okay, cool.
Yeah. So that essentially we should be able to just start navigating the tree. So it's a tree, so it should have a root.
We get to, we are currently, since we're currently sync, I guess we do async in a later episode. Let's start with the synchronous versions. So we have the syntax root, I guess.
Yes.
And that is a syntax node. Is that basically the compilation that we saw in SharpLab, the compilation root, if I recall?
Compilation unit.
The compilation unit?
I would expect so.
Cool.
And so it's actually probably easiest to, I guess. So, there's two approaches here. So we have a tree, and a tree is made up of nodes, and we currently have a node. So we can navigate through the children, and we can, essentially, I think there's a helper method called descend or descendants, child nodes. I think there's a descend nodes, yeah. So child nodes is direct children, descendants is everything, children and their children. And so we could iterate through descendant nodes, and if the current node is a using directive, then do something, etc. Or what we can do, because Roslyn's API is reasonably well designed to help out in these situations, if we get the compilation unit, which I think this should just be a matter of casting this to a compilation unit, the compilation unit should have a property on it called usings. So it's compilation unit syntax, I think. Yes.
Okay.
I'm nervous every time I say this because I don't know it off by heart. I just type and I use IntelliSense to help me, and same as every other developer. So, but sometimes I think I might need to sound smart in these environments. So this should have a usings property on it, I think.
Excuse me, I didn't catch it.
Usings, or
Ooh, okay, I never used the compilation Unix syntax. I will always use the compilation Unix. This is my new hammer now. Everything is a nail.
So this is where things get interesting. So if you can work on the syntax node and you can work on children, and it's all very generic. If you work on this compilation unit, we get usings. But usings are a C# concept, right? In VB, they're called imports. And so, you have to sort of... It can be sometimes easy to fall into a trap. If you don't know exactly what you're trying to achieve, you can end up not necessarily doing the wrong thing, but converting this code to use. You might think that this code looks pretty generic, and it does, but it wouldn't work in VB because in VB there's no using statements. They're import statements. So little differences like that stand out. But so we should be able to just iterate through this, and we're almost done.
So we have using a node, and that is of course an in.
Yeah. So is that, I don't know what type using node will be.
A using directive.
Cool. And so this is where you probably want to switch over to SharpLab. So now we have our node that we care about. If you click on the using directive here, and so getting to the node is the first part of the battle with Roslyn, and so we've got there. That was relatively easy, but now we want to get a very specific thing out of the node, and so I often then will come back to the tree visualizer here, and there is a tree visualizer built into Visual Studio as well, and there's various other sites on the net that do this, but sometimes, and for using statements, it's not, but sometimes pulling out the actual information you want can be a bit annoying. In this case, it looks like it's pretty easy. I think the way SharpLab displays this, I think this just means that there's a name property, and it will be of type identifier name syntax. And then that identifier name syntax has an identifier property that should say system.
And that's now a token, and the token has no more children. That's the terminal. That's the leaves.
Yes. Yeah, so tokens are the leaves in the tree. Every token is a node. Every node is a token, or every token is a node. No, every node is a token, I think. But yeah, anyway.
Okay. So let's see.
So this is where, to navigate through some of these things, it can be helpful to refer back. Of course, you could also be lazy and go using node.name.toString, and that will work as well.
Let's not be lazy. Because that is now a name syntax, but in here it says it's an identifier name syntax.
Yeah, so this is the class hierarchy of Roslyn at work. So a name syntax could be a qualified name, or it could be identified. So name syntax is like, it's an abstract base class. I don't know if SharpLab will show you that. Oh yeah, there you go, qualified name. Yeah.
So if I have dots, if I have more nested namespaces, then we see it's a qualified name that has a left and a right, which again is a qualified name, and then okay.
Yeah. So this is where, as I said earlier, sometimes working with the tree can be annoying because it's so detailed. Like all you want is what's between the space and the semicolon, But what Roslyn is going to give you is every dot, every word, everything. And so, again, sometimes you just call toString and you write the correct words. I think in this case we can. Yeah, no, we would have to do that because name syntax is not going to necessarily have anything useful that we could directly use.
So we would now actually, so we would need to write code that checks, hey, is it an identifier name? And if it's not, it may be a qualified name. Okay, so
yes.
I see.
And sometimes you need to write that code. Depends on what you're trying to do. But for this case, we probably don't. Yeah.
So this will be now the string, the identifier. And cool, I guess now we can build up our dictionary. So let's build our result. We currently expect it's a dictionary of string and integer. So we have, I think if you write like this would add or, hold on.
It will add or update.
Add or update. But I know I actually need to see if it exists here.
Yeah.
Is there like a method like add or update? I don't know.
I don't know either. This.
Recent try. Now let's go.
I would try get value probably.
So we try to get but it's an. Can we? No, let's see. So we try to get the value. So that's the current count.
You need to pass in the identifier.
That's yes. And if we find it, then we can't just say plus because that's a value type.
Yeah, you could do that. What I would do is if we can't find it, then set it to 0 and then just assign it back to the dictionary at the end. But it doesn't matter.
So if we can't find it, then we. You mean like. No, I'm not sure if I could follow.
So what we need to do is we need to know what to set the value to. So if we can't find it, then we're going to set it to 0. If we can find it, we're going to increment it.
You mean like so, and then eventually we will always set it.
Yes, because as you said, it's a value type, so we can we have to set it again.
I think there is some, there is some memory marshal helper where you can then get the ref or something, but I always forget how this works.
I don't know.
Okay, cool. Of course, no, this wouldn't work. So, but in the if we write else, or perhaps if we write else, is this in scope? Is the count? Oh, it is. Okay, cool. Also, because that actually, I think that what it does is basically declaring the count like integer outside of the if scope, right?
Yes.
So it does something like this, and then okay.
Yeah, and I suspect that if it doesn't exist, it will set count to 0 anyway. But strictly speaking, maybe we shouldn't rely on that. But I suspect that will work fine.
Okay, cool.
Just be safe.
Yeah.
And I guess this is okay. And then we return.
Yep.
The result, and
that's it.
I guess it's time to run some tests. So let's bring up our command line. We are here at our unit tests. Let's do a .NET watch test. And we have 12 failing tests. Okay, I expected 6 to pass because actually we do have, because there is the globalizer in as well that currently just froze.
It got some
so perhaps
results.
That's the globalize. Where were the counts? So the using counter is,
I think it was down near the end. It did output some dictionaries, and there were some non-zero numbers, but evidently not the right numbers.
Oh, there, yes. So we have.
Because we're starting at 0, we should start at 1.
Ooh, yeah, yes.
Classic.
Off by 1.
And now we have 4 passing. Okay, perhaps to make it easier. to, I'll just comment these out for the globalizer tests. So we have two failing. It's this one, for example, is failing because, but maybe I set up the test wrongly. We have system, so it's actually system 2, not 3. Let's see if I have the test correctly. So we have one system. Ooh, I guess, will we find, because we also have usings within a namespace, will we find that using that way?
Not with the code we have now. That's an interesting point. But do we want to?
Do we want? Ooh, because that would, if we would change, I'm always forgetting. So what's the difference? What's the actual difference? I always need to learn it again. What's the difference between putting it inside or outside of a namespace?
So it's all to do with how the compiler, or where the compiler finds the types you use. And it probably doesn't come up for most people. So that's why it's an interesting question as to, maybe it would be an option or something. Because I've certainly, I've worked in a code base where all usings go inside the namespaces, and I've worked in lots where they all go outside the namespace. And if you generally stick to one of those two, then you usually just consider them equal. But if you're using both, there are valid reasons why sometimes you need to move a using statement inside a namespace to help the compiler understand where something should come from. So for example, actually in your last episode where you defined two console classes and you got an ambiguous reference when you had both using statements, if you moved one of those inside the namespace, then it wouldn't have been ambiguous because that one will win and the compiler will choose the one that's inside the namespace. So you wouldn't want to convert that to a global using or you'd break your code.
I see.
But whether that's a real scenario or not, I don't know. Now we're back to me asking questions about what is this supposed to do?
So the default should not consider usings within a namespace because this could potentially break, but we could offer this as an option, like as a bit of a warning thing. Hey, I really like it's an
potentially. Yeah, I think for most people, even if they use using statements inside a namespace, they probably don't do it because of this resolution effect. But it could change things. Strictly speaking, global usings are outside of a namespace. So, if they've decided not to, yeah.
So, Eva, what would you say? Should we ignore that case for now and we visit it later?
It's a good question. I really like the idea of sort of having it optional because, yes, I think that would make it very usable for loads of different cases. And yeah, as you said, so if we just have the ones that are sort of right on top, and you said David, you said that you also worked with loads of projects where you had them all inside. Then the tool actually, unless we offer that option, the tool actually wouldn't work for them at all, would it?
Yeah, I think the problem is that I would say that my gut feeling says 90% of people who make this decision one way or the other do it for stylistic reasons, not because of the meaning change. But the meaning change absolutely is there. So you can't pretend it doesn't exist. And if you're writing a tool for general consumption, then I think an option is the way to go. If you're writing this for internal use at your company you work on, and you know that even though you have using statements inside the namespace all the time, you know that you do it just for stylistic reasons, then it would be fine to go and do it. But it does raise interesting questions. I mean, you can have nested namespaces and then nested usings inside those namespaces, and you can get 6 or 7 deep. So is promoting something from something 8 levels deep up to the very top, is that appropriate? I don't know.
Wow, I never thought about that. Oh yes.
This is when you start to write code that deals with syntax, you end up staring at, I end up staring at Visual Studio just trying to think of all of the possible ways this syntax could work to see if I can catch every edge case. And there's a lot of them. I mean, for example, right now, we are also counting using statics, which we don't want to count because they're not, well, maybe we do, but they're different. They're not the same. If you have an alias, we'll be ignoring that. But again, if we remove the one with the alias, that'll break your code. So there's more to even the code we've written, let alone worrying about namespaces.
We haven't thought of all the corner cases actually.
No, I haven't.
Actually, when we sat
There's a
together,
lot.
Eve and I when we sat together and we said, hey, yeah, let's build a tool. Which one? Let's do a using counter and globalizer because that's simple enough. Okay, that assumption was naive.
That's a very common assumption. Don't worry.
Okay, so if we were to, let's say, add a static using, we definitely want to ignore that. So using static system.console, for example. And also let's do an alias that we also would like to ignore.
So this is an interesting, an alias I would think we definitely want to ignore, but a using static, we probably don't need to. So this is where you have to really think about how C# syntax works. A using static can be made global. That works. It means system.console will be global, will be static in all of your files, but this tool is not going to do it automatically. It's only if you ask for it. So I think that's okay. A using static can be global. So it does fit in with the tool. What you wouldn't want to do is confuse a using with a using static and count it as one thing. They're sort of separate counts because you're asking for separate things. Now, the good thing is that in C#, you can't do using system.console and you can't do using static system because one's a namespace and one's a type. So there's never actually going to be the same thing in a using statement and a using static statement, like referring to the same thing. Does that make sense? So we can I think it should be fine to just count static and not have anything different. Aliases is definitely different because that's not true. You can have an alias type or a namespace. But I think using static, we maybe get away with just treating it as a normal using statement for now. Obviously, when it comes time to move them into the global file, different code will be needed. But yeah,
I didn't know that. So
I think that works. Now I'm second guessing myself.
I didn't know. I didn't know. Oh, cool. So I can say using my super system is system.
Yeah, that works.
Oh, wow. Cool. Oh my God.
I just had to check myself.
I'm doing it now for 10 years, but I think now after feeling only like 30% I know of the language.
Well, but don't forget, you don't need to know this bit. Like these bits, well, you do if you want to write this tool, but
yes,
for your day job, you probably don't need to.
Okay, so we want, like, let's go with this approach. So let's currently ignore aliases, but let's count statics separately. So I'm now just adding something naive, and I guess maybe later on we want to, I guess we also want properties. Hey, is this static true or false? But maybe for now, let's do it simple and say, okay, this is a static system.console, and we have 1. How would we do that? And also,
So this is, I think Roslyn will help us here. I think there should be a static keyword property.
Ooh.
So
Nice.
This is either going to be null or not null.
Is that's because it's okay.
So it's not quite a Boolean is static flag, but what it is a pointer to it's a pointer to the token of the static keyword. So it's a struct. So it's it should have should have an is empty or is defaults property on it.
Default.
I think is missing. Maybe
is missing.
Press. Yeah, I think that's correct. I thought there was a. Oh no, missing tokens are generated.
Do we need to check the kind?
Maybe it's just use default. Oh yeah, kind. That's
what default? Like so.
I think default will work. But yes, I think there's a kind. I think there's a kind syntax token.none is what I was.
Kind syntax
Is kind. Yeah. You have his
this keyword, sorry. Syntax kind dot none. Okay. So now it's not static.
That's right.
And in the else it would be static. Would the toString still, would it be, oh no, if we do the toString on the name, it would not contain the
Correct.
static keyword. Okay.
That's right.
So-
But of course, to answer that question, if you go back to SharpLab, let's have a look at the tree.
Yeah. So let's do a, no static using yet. Let's do a static, my console is .console.
Oh, static and alias.
Oh no, hold on, that doesn't work. Yeah, that's, there we go. So, so this will be a,
So there's the static keyword. And yeah, so the name is still just the name. The static keyword is the word static.
we see, yeah, it's only,
If the static keyword was underneath name in the tree, then our name.toString would break, but it's not.
okay, so for like naivety, let's just add identifier. It's not the most optimal thing. Actually, I need to prepend it. Let's add static in front of it. Then this is totally the other way around. Like so, for a naive approach.
Yep.
I guess we can invert that. Okay. And to test one again, now we do have one static console. Awesome.
Excellent.
Nice.
The system, that's the alias, right? System
Probably.
console. Let's have a look at the test. So the okay. So we want to ignore aliases. I guess back to SharpLab, right?
Yeah. Well, or you can have a
Oh.
guess based on what we know.
Okay,
so
well,
far.
it's
But yeah.
called alias, so that looks cool. So I guess in the beginning we can say if our using node's alias is not null, we want to continue. This one that-
Is
oh no?
yes, sorry, that's right.
Okay, and now we now still have the question about the usings within and outside of namespaces. I guess let's for now include them, and later on we make this optional to then include it only if some flag is set.
Okay. So that's an interesting off-the-cuff comment. So to include usings in namespaces, how many namespaces? So really what we should be doing here is we should be now descending into the tree, because you can have namespaces inside namespaces, which is
Going
not
to infinity.
we could do that. I mean, it's not hard. In fact, like I said earlier, if we just use the descendant nodes approach, that's sort of a naive approach, but it'll work. It'll visit every node in the tree, which is a bit of overkill, but this is for these tests, it won't matter. But the way that this now you have to think about things is, so compilation unit should have properties on it that let you get the namespace. That namespace will have properties to let you get the usings, and then it'll have properties to let you get the namespaces. And then we just either recurse or we use a tree visitor or some other pattern to visit all those. So I think compilation unit, doesn't have namespaces because it could be top level code.
Ooh, yes, okay.
It has something. What properties has it got? It's like members, maybe. Members. Yeah, so I think it's got members, and if it's not top level code, then the first one might be a namespace, but it might be a class. So
I see, yeah.
if you want to deal with syntax, you have to deal with all of the syntax.
Because we have here top level code, so this type is not within a namespace, or
That's right.
but I could have a okay. So So like the potential overkill solution, but simple approach would be to have a look at the descendants.
Yes.
And this would now get all of the nested using.
So yeah, what you would do then, and this is maybe the link approach you were saying, is you could probably just do descendant nodes dot of type using declaration syntax, using directive syntax. Sorry.
Are there more common or better approaches?
I think descendant nodes takes in a lambda to tell it when to stop looking, which would be a reasonable sort of performance game. Yeah, descend into children. So descend into children, you use that to tell it when to stop looking. And so in this case, you don't want to descend into children unless they're namespaces, because you can't have using statements in classes or members or etc. But again, for these tests, maybe it's not worth it.
Okay.
Consider, I guess that's a to-do for future us. Consider descent.
That's definitely a refactor to improve performance once you've got it operating on huge files.
So for now, we grab all of these, and I guess then can do something similar.
Yeah,
no, actually, it should be quite the same, right?
Identical, yeah. I think that should work.
Because they're still.
And again, this is
syntax.
Yeah, this is sort of the advantage of, I think, going syntax first. Is again, once you have a using directive, the code is the same. So whether you get that from a document, whether you descend through namespaces, the actual logic's the same.
Woohoo! Okay.
Nice, amazing.
Wow,
Oh, this is great.
That happened so fast. I didn't expect it to already run. Yeah, that's cool.
So now, if we would like to also use this from our tool, because so we do have our .NET tool that is currently quite exciting, printing to code or not to code to the console in red. Now, if we would like to, because in our solution, we also have a little project under test that we would like, well, later on, we want to like automate these tests via integration tests. For now, we want to do something rather something very use case specific. Where we explicitly, for example, I'm not sure if this is the right thing, but explicitly pass this project, super hard coded, and then see that those usings are counted as well.
Okay, that's not as specific as it could be. Passing the project is actually reasonably complicated. Because, well, what you want is the C# files. But if you open up that project file, there's nothing in it. Well, there's not much, right? I'm guessing.
Ooh, I see. Okay. So would you then for that need this entire solution?
Yes. Well, no, we don't. So if you open up the project file, I'll explain a little bit what I mean for the audience, because I think you know, but we'll pretend you don't. So if you open up that project under test CS proj file, so we know that this project represents, some amount of CS files, but of course this project has basically nothing in it. It's almost empty. So those 6 files are included automatically by .NET. But the way that works is actually quite complicated. So that SDK equals Microsoft.NET.SDK thing up there, what that does is there's some logic in MS Build that goes off and looks through your hard drive to find what .NET SDKs you have installed, and it picks the right one based on various rules and heuristics. That then loads up a whole bunch of code, and that somewhere in that code, there's a little line that says compile include equals star.cs. We don't have that line of code, and so we either need to not use a project file and just use file system enumeration to find CS files, or we need the whole .NET SDK MS Build infrastructure working for us. So in Roslyn, there is, as I said, there's workspaces, project solutions, etc. There is something that can do this, but it's not the normal part of Roslyn. Like it's not, it doesn't run in Visual Studio. It's not used. It's used to help tools like this. It's written to help tools like this, but it's sort of to the side of Roslyn. If you just were to create a workspace and then create a project and you tell it that this is the project file, your project will not have any documents in it because Roslyn doesn't run MS Build for you. Running MS Build is a whole other world of pain. So we can either use the helpers, or we can do it manually, or we can load from the file system. It's up to you.
I would like to use the helpers.
Okay.
Because I naively called the episode Roslyn Workspaces, so let's
Okay,
Workspace.
that's fine. Well, the helpers are extremely helpful, and I think it's about 4 lines of code, so we'll be fine.
Sounds
Cool.
good.
Yeah, cool. So where are we putting this code?
So let's start all in the programs, yes. And we we later on then do some modularization and put it then, yeah.
So we need 2 new NuGet packages for this. So we need our workspaces one we have already, but we need 2 more.
Ah, right. So do I still have that? Let's copy that into the tool as well. This approach. We need another item group.
Does the tool reference the library?
It does, yes.
So
it actually
would have
has,
got
yeah.
that.
Cool.
That's good. If you paste that back,
no, it does not. It does
it
not.
doesn't? Okay.
But it should. It should. It totally should. .NET add project. No, add reference.
I can. Yeah, maybe. I don't. Is it add reference or project add or add
reference? Then we do. I basically started to use Visual Studio Code recently, so I'm still naive with it. Slow. Reference. So where are we? We on the dot. No.
You got rid of reference.
Oh, I did. Thank you. Libraries, and there it is.
Cool.
Yes, this is the most common typo that I do. .end. Okay, cool.
Okay.
So we now also have the Roslyn Workspaces. Okay.
Yes. So our 2 NuGet packages is Microsoft.codeanalysis.workspaces.msbuild.
Workspaces.msbuild.
Yep.
I guess, how is that? Is that similarly versioned?
Yes. So this one is the one that understands, reads project files, and talks to MSBuild. This is going to do most of the work. We pop that in. But there's one more, which is Microsoft.build.locator. Because MSBuild has to exist already somewhere else. And so this package will find it for us. So this is not versioned the same.
Which version do we want to use?
That's fine.
Latest to get all the to understand.
Yeah.
So should we then actually in our tool, should we keep actually those versions all up to date so that we can deal with the latest CSProj files?
Strictly speaking, yes. It's probably not going to change, but the Microsoft Code Analysis Workspaces MSBuild will reference a version of MSBuild, so that will be sort of the important one if CS projects change. But I don't think they're likely to break anytime soon. But so those 3 should be the 3 that we need, and now we get to use them, which is So you have the path to the project. That's good. So the first thing we have to do is find MSBuild, and that is simply MSBuild locator dot register defaults.
This will be in the which namespace?
Yeah, that one. Yep.
So it's the same. One is using, one is inline.
Yes.
Yeah. Okay.
Yeah. So what that will do is that will go off and find MSBuild on your machine and register everything that needs to be registered in order to find these things. So all these things use DI, dependency injection, to know about each other. And so then now all we need to do is create a workspace, which is msbuild workspace.create. Yep.
Colon is msbuild. Yep.
Yep. And then there's an open project method. Should be.
Open project.
I think. Oh, wait. Yep.
And
And
this will get the path.
should do, I think that should be it.
And we have some, we could pass a, I have never seen an API that actually takes an iProgress. Oh, this is cool. And the cancellation token, excellent.
Yep. And so that project you get back should then have a collection of documents. That those documents you can then call get syntax tree or get text or, whatever we want to do.
Documents. Mm-hmm.
Yep.
And I always
So-
write this one.
Perhaps for now, just console.writeline the document.full path and let's make sure it works.
Mm-hmm.
Full path, dot file path.
To see. Okay.
I don't actually know what the toString of a document is. It might not be useful.
Oops. And we should get, an exception. No instance of msbuild could be detected.
Uh-oh. Now we're into territory that I might not know about. That's
I think-
surprising.
I think okay. So what if I have, if I have multiple .NET SDKs installed, will it take the latest usually?
I would have thought, yes, it would take the latest and it would, look at global.jsons or whatever. Maybe.
I currently
It does
only
support
have
.NET
one
Core.
installed.
Just actually, maybe we need to manually reference msbuild. I'm not sure if it does. No, Roslyn must. No, the Roslyn one must do that. Yeah, I'm not sure. Let's maybe poke around the msbuild locator API and see if there's anything.
So we could just do a Visual Studio instance. We could just msbuild paths.
Mm-hmm.
Would this be then?
Do you have? Oh, maybe. Do you have Visual Studio installed?
I do.
Oh, okay.
Should we switch to Visual Studio?
No, I was just thinking if you didn't, then because register defaults returns a Visual Studio instance, so I was thinking that might be a problem. But if you
I
haven't
see.
installed, yeah, no, I wouldn't expect it to run any differently. I don't think.
Just
Well,
trying to do something naive.
It's yeah, but it's throwing the exception before it gets there, isn't it?
The register default fields.
You should add
I see. Mhm.
you should add an alias for .end, by the way.
Yeah.
Yeah.
Yes, I should.
So yeah, maybe we should give it the path to msbuild.
So this will be under program.net. Where will be is it SDK? 702. Why is this somewhere else?
Yeah.
msbuild
Yeah.
PLL, is that the one?
Yeah, I imagine it's that. I don't know whether this expects an exe or A DLL.
Oops. Oh. Oh, which is the default, which is the MS build path. Okay. And this is void. Does not exist. Uh-oh.
Interesting.
Do we have something weird in our project setup? Why this doesn't work? Is it? I'm just trying something.
Try. Yeah, I didn't realize I was muted then.
Oh, okay.
I just took the file name off the end. Maybe try that.
Okay.
Is that a compiler error?
Should look. No, it looks good, doesn't it?
Oh, did you remove the package? No.
Also, yeah,
We
I tried
changed
to.
it.
Also, because I changed the target framework. Okay.
Okay. Hey, it worked.
Ooh, cool. Okay.
Nice.
Okay.
Found
Okay.
a lot more files than we thought, which is interesting. Something I didn't think of, but it found the global usings file, which is
yes. I just talked to in our dress rehearsal to Eva that we also perhaps need to take care of auto-generated files that end with .g.cs, so have this auto-generated comment in it. Yeah, we actually do sooner than later.
yeah. Yes, I mean, and this is the advantage of using MS Build, because obviously it has all of the smarts to do everything. So it found every file. Yep.
But sorry,
wow.
what did you remove just then? I didn't catch that. What changed?
So
What was
we
the
no longer
magic?
use the full path, but only the directory to where the MS Build DLL is in.
Yeah. So the error said directory not found, and the path we gave it. So
Oh yeah,
it was looking for a path. Yeah.
Nice.
Cool.
Well, I'm glad that worked, because that could have put a complete stop to things if we couldn't get So now we have. So what we essentially have now is the full Roslyn view of the world, and so we've got a project. There will be a solution as well. Obviously, it'll just have one project in it, but you can get back to it. Yep.
Sweet.
Or there's also workspace.current solution, which will point to current solution. That one.
So this will be the same if I do project. If I go back to the solution, this.
Well, kind of. I think OmniSharp's just confused. Oh, that's guess that. So project.solution and workspace.current solution are sometimes the same, but the current solution is the one that changes. So that's the one that moves forward in time, whereas project.solution will be frozen. So you got this project by calling open project. If we now modify that document, that current solution will change, but the project.solution will always be the same.
I see.
Fortunately, we're not doing that. but yeah, so we now, I guess, can just pass we can get the source code from the document, and we can pass it to our method.
So we have the using counter. Well, it currently accepts just a collection of strings.
Oh, that's
so
right. We're parsing it. We can make this better, because we obviously don't need to reparse these documents.
We now could pass in the doc. Yeah. So I'll add a overload.
Yeah, I think that makes sense.
For now, that now takes a collection of projects. No, hold on. No, we pass in documents.
Document, yeah.
Yeah, it's still documents. And now could.
So, yeah.
So, but we are. So we do parsing again. Okay. I guess I can go ahead and grab that.
I
Okay.
would
So copy
grab
paste will
one more.
refactor later.
Yeah, I would grab up even further though. So, I guess we don't need compilation unit anymore because we're not using it. But the method that you're about to extract, I think, should take the syntax root. Would make the most sense.
Okay, so we pass in syntax nodes.
No, sorry. So
No,
this
no.
one was fine. But so if you extract out from that method below, if you
Okay.
extract out the logic for given a syntax root, add these using statements to the dictionary that is passed in, that method then becomes very useful.
I see. So we, if I no, I just grab. No, that's okay. Confusion. So I want.
Can I offer a
Yes,
suggestion?
yes, please go ahead.
If you select, so scroll up. If you select from line 25, down to line 52, and then bring up the light bulb and extract method.
Ooh.
Roslyn should do it for you.
Oh.
Nice.
Oh. Okay. Okay. Obviously, never used that refactoring. Okay. Cool.
So the reason why this is going to be very useful, we talked about descending through namespaces and things like that. If you think about what this is potentially doing, we're giving it a node. That node could be anywhere in the tree. So we can actually use this method as a recursive method. If we end up changing the code to go through namespaces, we can call this again.
I see. So this isn't necessarily a
It's not
root.
Exactly.
It is
just
any
a
node.
Yeah.
And no. I always hit Control RR instead of F2. Syntax node.
Yeah.
And well, let's say populate usings or something. And okay. So now in here we could go through all the documents. Now we could get the roots. Okay, we could
if you just copy the method below, it's
right.
it's almost the same. And so the
So
only thing we need to do differently is how we get, so it's not a string. If you change that back to a var.
Yes.
But so all we need to do here is change how we get the syntax root. And
so from the documents, get
that's it.
Syntax root. Cool. We're not having async yet. I'm doing something very, very this pains, but okay. It's for now.
Just have a look. Have a look. I think there might be a synchronous method to get the syntax tree. No, there isn't. It must be. There must be. There is one, but it's probably an internal Roslyn helper method. But there is a get try. I think it's try get tree synchronously or something. But yeah, that's all right. If it works, it works.
Exclamation point. Okay. So we get the roots and then have a okay. Could this and then we would use the using counter and we count and we pass in the documents and we would get a
the collection of documents.
Yes, okay.
Though it would be pretty easy to create a method that takes one too.
So that's an enumerable. Okay. Enumerable. And now we could. Oh, is there an easy way to like print a dictionary to the console?
Not that I know of.
Other than getting the key values pairs and then printing all of them. Entry dot key Tree.value.
There's a comment from a jealous Java developer too.
Ooh. You're salty devil. Thanks for joining. As a Java Python dev, I'm always really envious of the amazing quality of life features that come with C# and Roslyn. This stuff is really cool.
It's also very addictive, and once you get used to being able to interrogate the syntax tree, you just want to do it for every problem.
Interrogate the syntax tree. Yes, I like that phrasing. And we do now get, oh yeah, okay. We also count the auto-generated global usings, but we do get our, we do have 6 files. All of them have the same usings. Where do the 2 system usings come from? Because our project has, I guess maybe from the assembly info?
Yeah, probably 2 generated files.
Because we actually have, so we have one using in the
assembly info and assembly
info and also assembly attributes. I see. Okay, cool. Cool.
And the global alias is interesting as well. That's another. I'm guessing, but I would assume that's another type of name syntax that we could, you could special case and handle, or, well, actually, I guess if it's a global using, we probably don't want to count it at all. So that's probably more likely the approach, but it found everything, which is nice.
So I guess if we hop back to the, where is Sharp Lab? There we go. If we have a...
Hang on, before you look.
Excuse me?
I was going to get you to guess before you looked.
Okay. So...
What would you think it would be?
A global key... No, not a keyword. So it's part of the... So, okay, we see that it's part of the name. So then it's like... So the name now is some...
I was actually thinking of the global. No, I was actually thinking of the global keyword.
Are they global keyword?
So from the
okay. I thought that namespace alias.
Those ones, yeah. No, I was thinking more of, we don't want this to count the usings in the generated file, but really we don't want it to actually count any global usings, because if the job is to convert to a global using,
I guess there is a global keyword that we can check if it is if the kind is none.
I would also guess that.
So the using node has a global keyword and the kind is
kind.
Is kind. Yeah, a kind is like an integer, isn't it?
Yeah.
Kind. If it's so we can actually ask more directly if it's global. If it's the global keyword, then continue.
I think there's even an overload of is kind. Oh, no, sorry. Yep, never mind.
Okay. And if we run that now, the globals are cool. Okay. You do get the 2 reflections from the assembly info and assembly attributes, and also +2 from these. So I guess we could then have a look at if they are like in the object. Okay, now, well, it doesn't necessarily have to be in the obj.
Do you want to take
folder,
the question off the screen, because we can't see the bottom of the screen?
Oh, sorry. Yes, my bad. Is there an easy way to ignore those generated files? Well, we could have a look at the path contains object, but I could rename this obj directory, I guess. So this doesn't sound to be also stable.
Easy way is an interesting question. There is. I'm just going to poke around the Roslyn API for a second. So one problem with Roslyn is that when you work on Roslyn, you get more API surface area. So there is a way to find out if the code you're looking at is generated, but I'm not sure that's exposed to the public API. But I would imagine those 2 files have an auto-generated comment at the top. Or actually they end in .g.cs, which is another indicator that it's generated. And it doesn't look like that is part of the public API. So
I have a déjà vu. Like, is auto generated or something?
so there's
Found this once in somewhere Stack Overflow. I found.
if you look for generated code utilities, you should find the thing I'm thinking of. Maybe there's another one somewhere. Yep.
Okay, so here we have the auto-generated comments and the .g or the file endings. Yeah.
Yep.
But that's internal. I see. Yeah.
Yeah. So I'd probably just do it, I guess, by file name. If the file path ends in .g.cs.
I think the global does, but these do not.
Oh, they don't.
But I guess since I'm also serving time, I'll add a to-do for FutureOS to
Fair enough.
to do ignore auto-generated files. C auto-generated code. C. Bloop. Okay, cool. That, by the way, is source Roslyn.io, which is the source browser to the equivalent of source.net, but for Roslyn.
Yes.
I posted it in the chat. Cool. So we can now count usings either by source or either via the workspace. I believe if we would like to change our testing implementation to also have a more workspace-y approach, I think this would be then the ad hoc workspace. Is that right?
Yes, that's probably, yeah. So the method takes a numeral of documents. So yeah, that makes sense. So yeah, so you would create an ad hoc workspace, which is essentially an empty workspace, and then you add a project to it, which will be an empty project, and then add documents.
Yet another to do.
Yeah. So the thing to be the trap here, something that as developers we assume is just going to work, similar to how you thought from a CS project was easy to get the list of C# files, and it's not. The same thing for references. So if you create an ad hoc workspace and you add a project and you add documents, that'll all work, and you can analyze the syntax, no problem, but you will not be able to get semantics because it won't compile, because you need references to everything, including system.object. None of that comes for free. So as part of your to-do, there's one more NuGet package I can recommend, which is called basic.reference assemblies. It's published by Jared Parsons, who's the compiler lead for Roslyn, so he knows what he's doing. And it is essentially shell assemblies for the entirety of the .NET framework. Yeah, so there's that one. That one is huge because it contains all of the .NET frameworks. If you go back to the search results, you can see that there's multiple packages for Net 5, Net 7, whatever. That you basically create your ad hoc project, and then you add references to basic.reference.assembly.net 7, and then everything will just work as you expect.
So we
for
get
.NET.
then, is this basically then containing the entire BCL to get that right?
The signatures of the BCL, yes, not the code.
The
It's
ref assembly.
still enormous. It's still multiple megabytes of a package. It's a very big package. But yes, at least all of the code that uses .NET should compile. And then obviously if you have your own code that actually references other things, then yeah. But yeah, that's the easiest way to get stuff up and running for tests. But just tests, because the code won't run. They're all empty methods.
Cool. So then actually we could as an input have projects, or perhaps we do it per project. So because the least thing is we want to pass a project and later on entire solution. So I guess then the input is a project, and then from the unit test we get to the project via a talk workspace, but from the real thing then via the MS Build workspace.
And you
Cool.
probably, project would be the largest thing you'd want to pass in. You wouldn't want to pass in a solution, because each project is going to have its own global usings. So a solution is more than one project, which means more than one built assembly. So they're not going to share anything. So you wouldn't want to necessarily make the same decisions about project A and project B. Yep.
On this level. Okay. Cool. I guess now. So we now have to do this for 7 more episodes.
Yes.
I want two more episodes out of that. So what would be the approach now for if you want to implement the the globalizer? So where we then would go ahead in a previous in our dress rehearsal, we already talked about it a little bit about corner cases. So like if there is no file that contains any global usings, we could create a new one. But if there is one already, we could add to that. But if there is many, what do we do then?
Yep. So I can talk about it quickly because I guess we're probably running out of time. Actually, if we go back to the using counter file, and then scroll down to our populate usings method, and on that using node, I believe there's a remove method. And so that should, if you have a look what that returns,
in new root, a new
root, yes. So
are we passing a root?
Oh, sorry.
Okay.
Yeah, right. You call it on, yes. So you call it on the root, passing in the using. So if you want to remove the using node, you can call syntax node.remove node using node. Yep. And that will return to you a new syntax node. So this method, as well as counting, or no, I guess it would be a separate method, but the bones of it would be the same. The general pattern for this sort of thing, and if you look at so the syntax node or using node, if you have a look at using node just in IntelliSense, you'll see lots of methods that start with. So username will have a with alias, with global keyword, etc. All of these are for modifying the using statement, and they all return a new using directive syntax. And so remove node runs on the parent, goes through the whole tree, removes that node, and then returns a new version of itself. And so that's so to modify the existing document, you remove the node. Now, what do you do with this syntax node? Well, in your method that calls this, you now have a different syntax node to the one that you got in your so here from your root. So you would call the document.with root and pass in that returned node. And then when you're dealing with projects, you call project.with document and you pass in the returned document. And so all the way up, you're creating these new structures at every level that is the modified, the modified structure.
No, hold on. Where is the with root?
So this is the pass. Next method up. Yeah. So this one. So C# document. Okay. So essentially, if you can get a syntax root, it means you can change a syntax root. So they're immutable, but you can change everything. You just get a new one back. Yeah. So you can kind of imagine the method that works on nodes returns new nodes. The method that works on documents or document roots gets back new roots. And then all the way up the chain. So that's how you would modify the document.
So this should then return so we pass in documents and we get back modified documents.
Exactly. And then, yes, the same thing further up. So that would be the removal. And then as far as adding a new document, that's actually pretty simple. You just add a new document. You just call project.add document.
So do I then remove the old one and add a new one?
I think there should be a with document text, maybe. No.
On the project.
No, document.with. No, okay, right. Document.with syntax root will return a new document, but that new document is part of a project already. I think.
Okay.
No, wait, maybe I'm wrong. Not sure about that. Okay. The thing I am sure about, though, if you go back to program.cs, the solution has methods for all of this. So if you go project.solution, yeah, dot, and then if you look at, I think it's with, should start with, yeah, with document text or with document syntax root. Is probably what you
syntax
call.
root.
So that will find the document, replace the root, and that should give you back a new solution.
So pass in the ID of the document and also the new root.
Yep.
Okay.
Now, the thing is, for this tool, you probably don't need that because you have to write these out to a file. So the document text is actually all you need, and you'll have to do the file writing yourself. So like if you call project.add document, it will add a document in memory, but it won't create a file on disk. Roslyn doesn't do that.
Okay.
So this creates a document and it adds it to the project and it adds it to the solution, but none of this exists on disk in the same way that Roslyn doesn't sort of natively support automatically loading things from disk. Yeah, so you probably just go through the documents, and when you get given a new document, you just go file.write, and yeah.
Okay, so that's okay. So we use system.io.file to actually produce the file. Again, assuming it's a C# file. Yeah.
Yes, but yes, yeah. So your program here is essentially the host for Roslyn, so it has to do that work. Roslyn is just reasoning about stuff. And so you might want to add the document to the project if you're going to use the project later for something else. It still might be valid to do, but it's not, the end goal here.
So this is now to create the new global using file if it doesn't exist yet. And how do we then exchange the existing? So if we set for this project a new root for each document, or potentially, then we get a new solution each. So assuming we have we have two documents, we would have two new solutions. How do we apply that? Previously you said something with apply to workspace or to solution. How would we now store that new solution?
So you get a new solution when you change a document, and then when you change the next document, you do it on that new solution and you get another new solution. So you move forward in time one step at a time, but you always operate on the latest one.
I see. Okay.
And then there's a workspace. I think there's a set current solution, but there's also like try apply changes, that sort of thing. For this program, it's not going to matter because nothing else is operating on the solution. Nothing else is operating on the workspace. So there's not going to be any conflicts. It'll just work.
Well,
but also, technically, you don't actually have to do it because nothing else is using the workspace. So
I see. Okay. Not even what if like the user in the meantime while our program runs, and the user would in the meantime change the source code?
Nothing in Roslyn will read the file system. So if the user changes the files on disk while your program is running, Roslyn
we overwrite their changes then.
Yes, and Roslyn won't notice the new changes because it's not monitoring the file system. That's what the host does. Visual Studio does that. So your program could do that if you want to.
I see. I misunderstood that. So this is really only on the workspace. So if we would run multiple tasks on that same workspace, or no, on that solution, then this could return false and fail. But since we only have one, okay.
Yeah, and this is for like if the workspace is long-lived and you're going to keep working on it, and possibly there's asynchronous code that needs to access things. Like this is where this comes into effect. For a .NET tool that should run and then finish, it's kind of overkill. It's kind of, strictly speaking, you should have using that workspace because it's disposable. But at the end of your program, your whole program is going to go away anyway, so it doesn't really matter, right? Like, yeah.
So for a console application, we don't need to care about that. If we would write our own IDE,
exactly. If you're running your own IDE, then your workspace would then be long-lived. There could be multiple users or people doing things at the same time, and you need to manage some more of that. Yep.
Cool. But this actually now would, if I now try to apply the changes, would this actually then write the changes to disk of the existing files? No. So I would then need to go ahead and overwrite those files via file replace, or I'm not sure what the API that is.
And that's why it kind of doesn't matter whether they're in the solution or not.
Now I understand how you entered that workspace is maybe total overkill because
Yeah.
just parsing the files and okay. Mhm.
Yeah.
Okay. Well, I guess understanding if there is an existing file that contains global usings and if there is only one, I guess there the having the projects.
I mean, so you need a workspace for MS Build stuff to work. So you sort of need to have it, but once you're applying all these changes and you're getting back new snapshots, this program is simple enough that you can just keep operating on those new snapshots. You don't need to save them anywhere. Like when you apply the changes to the workspace, what you're really saying is save this snapshot in memory as some version. You don't kind of need to do that because everything's in this synchronous code, and you just, if you go through each document and get a new root and apply that and get a new solution, and the next time through the loop, it just uses that new solution, overrides the variable again, that'll work.
I see. Wow.
Wow. This was, we've got a lot of work ahead of us, but this was really, really useful.
Only as much as you want.
Well,
this is part of the reason why I don't have any NuGet packages for general consumption because there's too many edge cases and I can't be bothered. I'm very lazy. So I have my stuff and I use it for me. And if someone else uses it, that's great. It's all on GitHub. I'm happy to share, but I don't want to have to make it all work all the time because yes, things get complicated pretty quickly.
True. But I think we're set up well for our next for our next stream. Do you have any more things to add, Stefan or David, before we move on? I mean, we're a little bit over time already. Just being mindful of that.
I mean, I can't think of anything I can't think of any traps that you could fall into. I think it's you're pretty well set up here. I guess, you're finding the syntax nodes. So when it comes to removal, you'll have to find them again, but that's okay. Removing them should be straightforward. Generating a new file is pretty easy because you just write it to the file system. So I think you've sort of got everything tricky.
Cool.
Yeah, I can't think of anything else.
I'm confident. I believe in us. I also believe that we will still fall into some traps, but that's part of the experience.
Exactly.
Okay, when is our next stream? I seem to remember.
To find
13th?
the right tool. Yes. Okay.
Yes,
For some
13th
reason
April.
now the formatting here is a little bit weird, but
It looks quite nice. It looks really
funny.
cute. But yeah, it's supposed to be a calendar. It's a Thursday this time, the 13th of April, and we've also included the Australian time at the bottom.
No offense, but I won't be tuning in.
It's okay. So yeah, I guess it's the 14th for you guys actually. Yeah. Interesting. Yes, and so that's what is that? That's just over. It's not quite 2 weeks ahead of time, but we've got loads of things that you can fill your week with if you're craving new content in between. Yeah, we always want to just recommend a couple of meetups that we sort of like and we try and attend. And it's the mini hack, which is sort of hackathon, I think, which is online, so everybody can join. Again, Australia might be a bit tricky because I think it's European as well, isn't it?
Yeah.
Yeah.
Yes.
I think it's hosted in the UK. So yes.
Yeah. And yes, we've got the .NET Day at Azure Developers, which has there's so many speakers and content. So I think there's something there for anyone and everyone. So have a look at that if you're interested. Then next is my favorite. I love this. It's on the 11th of April, and I've had it in my calendar for I think a month. But yes, the .NET meetup in Vienna. It's also remotely. So it's also you can access it remotely, or you can come to Vienna and hang out. And one of the organizers is here today with us. It's our one and only Stefan, who's co-organizing this event, and it's always so much fun. So absolutely, like if you can, do join. And last but definitely not least, David has a talk coming up as well. He's speaking at Adnam, at Adelaide,
Yes.
Adelaide in Australia.
That's right.
So
Yep.
yes,
That one's a good time for me.
yes, on the 12th of April. So yes, do stop by if you can.
About Hot Reload.
Yes.
Yeah. Although mainly about .NET DLLs, because Hot Reload's not that much to talk about, but it's fun.
And while we had a look where Adelaide is, we also did a fun little comparison of
yes.
Adelaide. I was saying wrong. We did a fun little comparison of how small Austria is compared to Australia. This gives some perspective.
Yeah, so I'm in Melbourne, just at the bottom there, and Adelaide. Adelaide is the capital of the next state over, South Australia. So going on a bit of a family holiday, driving over, and since I'm in town and I know the organizer of the Adelaide.net meetup, I said, I said, what date is your April meetup? And he said the 12th, and that happens to be smack bang in the middle of where I'm there. So why not?
Cool. Great. Then I guess we are at the end. Your Salty Devil says, thanks everybody. That was really insightful. Will this be uploaded to YouTube? Yes. So when we stop recording in like 60 seconds, it will be available on YouTube. It will be available on Twitch as well for, I think, a week is the retention duration there usually, but forever, as long as YouTube exists, then over there.
Yes, and cool. I guess all that's left is say thank you so much, David, for joining. This was really, really amazing. I think we've all learned a lot, and it was a pleasure having you on the show. Thank you so much.
Thank you. It was great fun. I love chatting about code.
And until then, we'll be back.